Okay, let's go ahead and get started. Hello, everybody. My name is Eric Syme. I'm the Director of Program Management at ProSoft Technology, and I handle product management responsibilities for our industrial communication gateways, and specifically this IEC 61850 protocol. So today I'm going to go through some of the benefits of IEC 61850 and how it can help you with some of your applications, saving time, commissioning effort, programming effort, and things like that. So when we talk about industrial communication protocols, those are used to allow devices to exchange data between each other. And by having a communication standard or a protocol, devices from different vendors can communicate with each other. Specifically, in some power generation and distribution applications, there's been some common protocols over the years that have been typically used. Protocols such as Modbus, DMP, IEC 60870 -5 either 101, 103, 104, and then now IEC 61850 have really kind of dominated the space for IEDs in power generation and distribution applications. And one of the main reasons is some of these protocols were designed specifically for power applications. And so that's allowed them to proliferate through those applications. So when we look at IEDs for the power applications, they're used throughout an installation. And these IEDs are used for anything from IED integration to substation automation, and then eventually passing that information up to what's referred to as the utility enterprise level. The rise of Ethernet has really changed how devices are connected throughout the substation or connected to SCADA. And IEC 61850 was one of the industrial communication protocols that basically started to really take advantage of Ethernet messaging and some of the benefits of using Ethernet for these applications. So IEDs are various protection and power devices from vendors such as General Electric, Schneider Electric, Siemens, SEL, or ABB is also another common vendor. So some of the common protocols that I mentioned for IEDs in substation applications is typically Modbus, DMP3, and then the IEC 60870-5, 101, 103, 104 protocols, and then now IEC 61850. And so just to give you a little history on some of the things, this will help to recognize the benefit of using a newer industrial standard or protocol such as IEC 61850. Modbus communication was something that was developed back in 1979 by Modicon. It, for a long time, was the de facto standard for most communication applications. And really because it was a simple protocol, it was fairly easy for vendors to implement, and it was able to get the job done and move bits and words without placing too many restrictions on vendors. It was a master-slave relationship where a master device pulled data from the IED, and then the IED responded back with the data. Really, one of the issues that came in was if you looked at some of the addressing that you had a lot of times with Modbus devices, there really was no description to the address. So you would have a Modbus address like 40,001 or 0421, and you had to look at documentation to figure out what that actually represented as far as like the phase B current angle of an IED protection device. So in 1993, the DMP3 protocol was released, and this had benefits over various other protocols such as Modbus, where you were actually allowed to group data by various object classes. And so you had data objects such as binary inputs, analog inputs, counters, binary outputs. So you were able to group data. The protocol or the standard actually came up with a method of grouping data. However, it still wasn't very descriptive to an operator. You would have something like binary input index 0 was the relay in service, or trip condition active was index 1. So really, when we looked at IEC 61850, it was essentially a culmination of years of industrial standards and protocols that really had failed to meet the requirements of substation applications. And so it's an international standard for substation automation. It defines the communication between devices in the substation and related system requirements. And as part of the standard or the protocol, they essentially described a structure for addressing interoperabilities of IEDs. They described a common configuration language, as well as implemented a data model approach. And really a lot of this came from the fact that if you look at Modbus or you look at DMP or even the IEC 60870 protocols, those all started out as serial protocols. They either operated on RS-232 or 485, so networks with very low bandwidth. IEC 61850 started out and has only operated on an Ethernet network. So they decided that they wanted to take advantage of that bandwidth to really go ahead and address some of the issues that they had seen in the implementation of other networks. So when we look at one of the reasons why to use IEC 61850, if you look at, like I mentioned, something like a Modbus device, you basically had to set up registers for 40,421, and that represented a phase B current angle. Or if on DMP networks, you had something like an object 30, variation 2, and then an index that you had to go ahead and represent for a phase B current angle. So really the data address and the index was not self-descriptive. It really, from an implementation standpoint, somebody that was looking at this doesn't really have a good indication of what that information represents. And with IEC 61850, what they did was they took advantage of an object name structure in this data model approach, where they broke things into logical devices, logical nodes, data, and data attributes. And so throughout this structure, it provided a very descriptive tag name that could be used on the device side, as well as on the substation automation side. The other thing that they did, which was a great approach, was to really make the data model approach vendor neutral. And when I talk about vendor neutral, essentially what I mean is the community or the standard for IEC 61850 has implemented something like an XCBR, which is a circuit breaker data model. And that XCBR has attributes that are required for every device vendor, that it's the same for every vendor. And so if one vendor from, say you have the vendor GE, Schneider Electric, Siemens, or SEL, that XCBR data object in any one of those devices is going to be the same. And so that allows users of the IEC 61850 protocol to not necessarily be locked down with a particular vendor, but it also makes the implementation of devices much easier because you know what information is going to be required, and you know what the structure of that data is going to be. And so you've got something like the Relay 1, XCBR, LOC, and then ST val is the status value right there. So as part of the IEC 61850 standard, they basically outlined a series of data objects for everything from circuit breakers, disconnectors, switch disconnectors, transformers, surge arresters, and so there's basically all these different data object models that are already as part of the IEC 61850 standard that any device that goes ahead and supports that has to know how to recognize. So where does this really help? Well, this data model approach really can provide a great savings of up to 75% in configuration time of devices. And really, one of the benefits of this, and I'll actually talk about this a little bit more in a couple more slides, but is the data object model approach allows you to reduce the configuration efforts because it's a lot closer to a plug and play environment, and you get some self-descriptive tags with the right device. Those self-descriptive tags can be provide a lot of value right there. So when we talk about IEC 61850, we've got a couple of our products that have recognized and taken advantage of some of the benefits of this industrial communication standard. So the PLX82 EIP 61850 module is essentially it's a 61850 client on one side and then an Ethernet IP adapter on the other. So it allows various substation automation equipment to be implemented into a Rockwell Ethernet IP environment. And some of the things that we did with this module was we have a configuration manager software. And what this configuration manager software does is it allows you to bring in configuration files from the various IEDs that are used in substation automation. And those configuration files basically define all the data that's within a IEC 61850 device. So if you think about it in regards to like Ethernet IP networks, these configuration files are similar to EDS files. If you think of it in regards to like a Profibus network, these configuration files are similar to GSD files. And so these files provide the ability to tell a configuration software such as our configuration manager exactly what data is available in that device, and then it allows you to map that information in a drag and drop type environment. And so essentially we can go ahead and grab information from a device such as here it's shown as a Schweitzer SEL 700G, and we can go ahead and map information from that device. And the nice part about it is we maintain the device name or the 61850 data object model all the way through. And so if you are using a software to look at data from a protective relay from Siemens or ABB or Schweitzer or GE, if you're looking at a tag name such as LLNO this tag name right here at the top, LLNO, ST mod, ST val. That tag name is going to be the same all the way through. So that same tag name that you see in the configuration software for the relay is also now going to be the same tag name that's used in the application side. And so where this is incredibly beneficial is the software, our configuration software actually exports all of the tag name and the data objects based on your configuration, and does all the mapping for you. So if you're bringing this into a Rockwell environment, it really goes ahead and can save tremendous amount of time in commissioning and setup effort, as it goes ahead and automatically generates the PLC code and the user-defined data types, and all in a single add-on instruction. And so again, that, like I mentioned, that same tag name, that LLNO _ ST _ mod ST val, that same tag name that was used and defined as part of the IEC 61850 protocol standard is actually brought all the way through into the PLC code. So as you're commissioning an application, no more do you have to look at Excel spreadsheets and other devices where the substation automation guys looking at Modbus address 40,001, and you need to now look into a separate tag to figure out what 40,001 actually represents. So it really helps to save tremendous amount of time, being as the automation side is utilizing the same tag name as the substation part. So again, as we just looked at the protocol support on it, the module itself operates as a Ethernet IP class 1 server and can support up to 20 IEDs with up to 10,000 bytes of input data. So these are just the general specifics on the module. Now, one area that we've been able to work with Rockwell on to go ahead and take advantage of this IEC 61850 protocol is the library of electrical protection devices. So essentially, Rockwell Automation has published as part of their plant PAX library some common faceplates and code for Schweitzer relays, ABB relays, and GE multi-line devices. And that is all based on the IEC 61850 protocol and some of the features that we put in for in the configuration software of our module. And so what this does is this now, in addition to having the ability for the Ethernet IP 61850 module to generate custom code based on your configuration, you now have a standard faceplate that can be used in your applications based on the type of device that you're looking to implement, such as here showing a Schweitzer Electric 700G. And so that just greatly helps in the implementation of the system and helping to get you configured, up and running, and the system implemented in a faster manner. So one of the projects that we worked with a customer on with this module was a powerhouse. And so what they did was they went ahead and implemented multiple brands of ProSoft products, everything from our PLX82 EIP 61850 modules to some MBI 56s and some of our wireless communication as well. And they specifically were communicating with SEL equipment such as a 751, 751A, and 700G device. And the old way that they were implementing these systems, they were essentially using the Modbus TCP/IP network to gateway device from the relay vendor. And then to get that data back into a Logix architecture, it was implementing essentially the ProSoft NVI56E MNetC module. And so a lot of the information that they had to keep in offline Excel spreadsheets, since it was a Modbus to an IEC 61850 conversion. They also had to utilize a 611 IEC 61131 programming language in the data concentration device to go ahead and map information from the relays back over into this device. And so really, they had indicated that a typical system, commissioning, programming, setting this up, and installing everything would take them somewhere around a week to go ahead and get all that set up. What they were able to do is switch over to the IEC 61850 gateway module. And because the configuration software would import the CID files directly from the 61850 devices, it would allow us to go ahead and generate all the tag names. That tag name that was seen in the PLC code or in the Rockwell code was the same tag name that was used all the way down in the device relay software. So this allowed them to increase their visibility. Because of the ease of implementation, they actually expanded the amount of data that they were supporting and provided a lot of benefits for them right there. Also, we've got another 61850 gateway, which is our Modbus TCP/IP to IEC 61850 gateway. And this gateway has a similar configuration environment. It's basically this particular gateway allows us to do communication with Modbus devices instead of Ethernet IP. And same thing, it imports those complex data structures from the IED device. It allows you to map that over into Modbus data. And really with this module, it allows you to it does some custom data mapping and exports Unity profiles for some of the quantum, the Schneider Electric processors. And so similar to some of the custom data mapping that we did with the Rockwell and the Ethernet IP side, this Modbus gateway to 61850 gateway will allow us to essentially generate variable files for XSY and XFM function blocks that can be tied directly into a Schneider Unity Pro software environment. And so again, this helps for customers that are looking to implement these systems, a 61850 module into a Schneider Electric application. It helps to generate some of the files directly for that configuration software, and then it goes ahead and maintains the IEC 61850 data object all the way through into the Unity Pro configuration environment. But the module itself does not, since it is just a Modbus TCP/IP client or server device, it can be used with other non-Schneider Electric devices as well, and just operate as a independent gateway device with support for up to 45 IED devices. And when we talk on the 61850 side, a lot of there's a couple different types of data messaging. Some of the most common data messaging is something like the MMS read and write. That's some of the typical data messaging that's used for SCADA communication. Then you also have goose messaging, which is some of your high-speed burst messages that are actually sent directly from the IED devices. A lot of times those are used for communication between relays, but we also do support being a goose subscriber. And then lastly, we've got some reporting functions that is implemented within the IEC 61850 standard. So that was really just a quick introduction to the IEC 61850 protocol and standard. And so I hope that you guys got some information out of that. I did receive a Q&A session in the chat that was asking about supporting a ring type communication. Just go back to this slide right here. Currently, with the hardware implementation that we have, this module can operate as Ethernet IP on one port and then IEC 61850 on a different port. It does not support all of the, there's some redundant ring configurations that some of the protective relay devices have started to implement. And this gateway module currently does not support the redundant ring networks, but we are looking to enhance that platform or our 61850 to be able to eventually support that features. So but right now it is a simplex, not a dual redundant ring. So thank you for the question. There's another question that came through regarding getting sequence of events data from the IED. So sequence of event data is typically brought through as report information. And we can go ahead and be a subscriber to a report. When we talk about bringing in sequence of events data, when you look about mapping sequence of events over to Ethernet IP or Modbus TCP/IP, there is really no sequence of events data structure that is outlined in those two protocols. So we can go ahead and grab SOE data from an IED. The key thing that you need to look at is if it's something like sequence of event data that occurs within on a device like a recloser or something like that, where it trips and closes multiple times within a very short period of time. You have to make sure that in order to see all those changes, you can go ahead and get information on the other protocol drivers such as Ethernet IP or Modbus TCP/IP fast enough to be able to recognize that sequence of event data. So that's a good question. It's a little difficult to explain, but yeah, it was a good question. There was a question that came through regarding the configuration software. Is it free or license-based? Our configuration software is actually, you can download it directly off of our website, and it is a free configuration software. So really it's a tool that allows you to go ahead and import CID or ICD files from various protective relay devices and then map that over for our gateway. So it is a completely free software. And another question came in: if a change is required after the configuration complete, is it hard to update or add tags? It is not. You can go ahead and update and add tags. Essentially what you'll have to do if you're importing that information into a project like a Studio 5000 project, if you added new data, you would have to go ahead and essentially import the new add-on instruction to overwrite your old one. And so that's about it right there. There's a question: max relay, number of max relays that you can connect to a client. On the Ethernet IP version of the module, we support a maximum of 20 relays. On the Modbus TCP/IP version of the module, we support a maximum of 45 relays. And really, that's just Ethernet IP is a little bit more strenuous protocol from a hardware perspective and requires a lot more resources. And so we just had to support less devices on the Ethernet IP version. And there was a question that came in regarding multi-master access to IEC 62850 devices. And I just wanted to touch on that really quickly. Multi-master, a lot of times there's quite a bit that you have to do for multi-master. And essentially, one of the things that you have to do is make sure that you have a slave device or a server device that actually supports it. It has to be able to support multiple socket connections from two different clients. If you have a device that supports that, then it's pretty easy to set up multiple master for read access. Now, if you get into a scenario where you're wanting to write, that's where you really have to have a device that's designed for multiple masters so that it knows to only write from one or the other device. And we don't specifically have support in our module for that right there. There's another question that came in regarding, is it possible to get timestamp from the relays? And yes, time is, as part of a data object, there is essentially there's a ST val, and let me switch back over here real quick. Sorry to jump around, but so here you go. So right here, if you look at this LLNO ST mod, ST val is your status value. Whoops, sorry about that. ST val is your status value, Q is your quality, and T would be your timestamp. And so what we do is we basically bring the timestamp value that comes directly from the relay and then pass it into the control logics processor. We display that as basically a lint data format in the control logics processor, passing that timestamp value over the relay, over the other network. So yes, you can get timestamp directly in the data object. And then there was another question that came through whether it was possible to do the same in Unity. And again, in the Unity configuration environment, you can do the same thing as far as bringing, unfortunately, I only show ST val and Q here, but yes, you can bring the T back in there. Here's the T right there. And within the Unity software, it's an array, 4-byte array, or 4-integer array, as it shows up in the Unity software right there. All right. Well, I think that answered all the questions right there that I've seen come in the chat. Thank you for, you guys had some really good questions, and apologize for us running over a little bit, but I appreciate the questions and the feedback. And if there's any applications or further questions that you have, please feel free to reach out to us. We'd be more than happy to help you and answer those. And if you've got some potential applications that you would like us to review or look at, please let us know, and we'd be more than happy to see how we could help there. And appreciate everybody's time, and thanks for attending, and there will be a copy of the presentation sent out via email link shortly coming up. So like I said, if you have any questions, please feel free to reach out to us. Thank you, everybody.